Okay, so you can have an ellipse that goes like this. Something like this. And that's what we've shown before. You can see a picture of that. It's on your paper. I always call that like a pancake ellipse. Okay? And our ellipse for right now are going to be centered at the origin. Okay? So that's the center. It's not really very drawn very well. The next picture will be better. But an ellipse that goes like a pancake, I guess, a flat one, that has the equation x squared over a squared plus y squared over b squared equals 1. That is the standard equation for an ellipse centered at the origin that makes kind of the pancake shape. If you have a vertical one, so an ellipse that's going like more up and down, that's going to be x squared over b squared plus y squared over a squared equals 1. And in both of these cases, a is greater than b. So when you have the larger number under the x, you get a flat pancake. When you have the larger number under the y, you get the vertical shape, or like an egg shape. So I always call this a pancake and this an egg. Okay, but they're ellipse, and picture of an ellipse. And these are centered, both of these are centered at the origin. Okay, so that would be the origin there where the axes are crossing. And you might say, well, what if A equals B? That's the case where it's a circle. Okay? All right, now we're going to go into the details what everything is called. So here I have an ellipse, like a pancake-shaped ellipse. I'm trying to draw my axes a little more accurate. And so we have a center, and that's important. But in this case, we're saying the center is the origin. Okay. And then we have foci. Okay, so we talked about that in the last video. That's important to the definition of an ellipse. So maybe I have one here and one here. And so those are called, well, one is a focus, and together you have two foci. Okay. Okay, so that's how that works. This distance here is called C. And it's the same distance away from the center. We haven't really talked about C yet. We have an A and a B in our equation, but we haven't talked about C. We'll get to that. Okay. Now, this right here and this right here, those are actual points on the ellipse, and they're called the vertex or vertices. So this is a vertex, and we have two vertices. Okay. And as we go to graph these parts become important to us. This right here is called, there are also points on the ellipse. It's called a co-vertex. For two of them, you have co-vertices. Okay. This graph's going to get hard here. This distance between the vertices, this distance right here, that's called the major axis. And then this distance here between the two co-vertices, that's called the minor axis. Okay, so just one more thing. It's my thing's getting all lots of drawings on here. The distance between the vertex and the center is A. And the distance between the center and the co-vertex is B. Okay? So that's how that works. So the major axis is 2A. It's twice whatever A is. Okay, because you have an A to the left, another A over here to the right. And the minor axis is equal to 2b. We have a b above and then a b below. And then the relationship for c, so this is important. We did c in green. C squared is equal to a squared minus b squared. So if we need to find where the foci are, we have to figure out what c is, and we can do that if we know what a and b are. Okay? So I know it's kind of all crowded in there, but that's the way it goes. Your vertices are at plus or minus b, comma 0. I'm sorry, that's an a, not a b. Pardon my drawing. The vertices are at plus or minus a, comma 0. And then the co-vertices are at 0 plus or minus b. Okay? And I think I've got everything in that we need to know for, that was a pancake-shaped one. So remember the equation for this one was x squared over a squared plus y squared over b squared equals 1. Okay, now we're going to talk about the other one. So this will go a little quicker. The equation here is going to be x squared over b squared plus y squared over a squared equals 1. It's important to remember that in the standard form, these equations, it equals 1. So now we have the axes going this way. Well, yeah, that's a little low. Let me fix that. Okay. Try to get it more in the center. Okay, so there's the center, which is still at the origin for now. And you can see this distance is going to be a, and this distance is going to be b. Okay, so the vertices are here and here on the y-axis. Okay, so let's see, I'll write over here. The vertices are at 0, comma, plus or minus a. And then the let's do the major axis first. The major axis is now going to be the vertical line here. That's going to be equal to 2a. And then the co-vertices are going to be, all right, this is going to be b. Oh, I already drew the b in. Okay, so the co-vertices are going to be plus or minus b, comma 0. Okay, and then the minor axis is still 2b. All right, and we got the center. The foci are going to be in here. So just remember that the foci and the vertices, they lie on the major axis. Okay. And then that distance is c from the center to the foci. Okay? And so I guess we didn't put this on the last one, but the foci are at 0, comma, plus or minus c. So let me go back and scroll up and put that up here. So the foci for the pancake shape, that's going to be plus or minus c, comma 0, because the major axis goes the other way. Okay, so hopefully you got all of that. I didn't draw the major axis and the minor axis in, but I can. So here's the major axis coming through here, and then there's the minor axis coming through there. So major axis and the minor axis. Whoops, I drew it to the wrong one. Darn it. All right. Get that out of there. Minor axis. Okay, anything else we want to know on that? I think we have it all. Okay, oh, just the relationship. C squared is still equal to a squared minus b squared. Okay, so that's all the details for the two types of ellipse.